All right, I'll go ahead and get started. So let me go ahead and go over the five. So there's probably going to be more than 5 questions, but so far I have 5 questions that I've determined will definitely be on the final. So, so here's what each of those 5 questions so far are about. Anything that's different, anything that's otherwise, will basically focus on those. So I will. Toddler, hold on 1 second. You want to watch what? You want to watch Frozen? Yeah. Okay. Okay. All right. So, I not yet. So I don't. So right now I have 5, probably 7 coding questions at most. So question 1 is a loop. So question 1 will be a loop numerical question focusing on modular arithmetic and if statements. Okay. Question 2 will be a here's a file. Please read stuff from the file and find things in this file that meet this field. It's going to be a CSV file. You're going to write through it. So I might ask you. So this is just like that question on exam 2 where I asked you to find like the biggest thing or this one. Here I'm just gonna be. So here you're gonna want to know how to split things, and then how to get an individual field out of the thing you split. Question 3 will be a question that will be solvable using regex, but you don't have to use regex to solve it. Is kind of my idea. So as opposed to, so you can use regex, you can decide not to. It's not starting. Oh no. Ow. Ow, 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 ow. You're right. It wasn't starting. I'm sorry. All right. So, third question will be something for regex, but you can also probably solve it without regex. That's my question. Question 4 I've got will be a turtle question. That should be much easier than doing it on the actual, on exam 1 because you're going to have access to the computer, right? So I'll probably do something like here's a picture. Please replicate this picture. I don't plan on making it too tough, right? So, or I might combine it with file reading, or I might decide to combine that with file reading and do something like the hurricane tracker. Okay. Question 5 is going to be another Monte Carlo method scam, just like you had in exam 2. So, sorry that I get the details to you so late in the game, but I had to go through and grade all those exam 3s yesterday for everybody. Excellent question. When is the final exam? That seems like important and pertinent information. If you go to your Temple if you go to your Temple final exam schedule and look at the doc. Right? So you go. I mean, I find it out the exact same way everybody else does, which is 4. So let's see. So we meet from 12 to 3:20. So that's this Thursday from 1 to 3. Question 1 was basically one that requires you to write a loop that had if statements and use modular arithmetic. So, testing you on loop, conditionals, logic, modular arithmetic. This one will be easier than it would normally be on paper because you'll be able to test your code. Okay? I'll probably actually move that one to the end or something because otherwise you might waste a lot of time on it. So, I'll try to order them in I'll try to order them. Most of them will have rubrics. Some of them won't, because rubrics would be, because in that case the rubric might be a spoiler. Okay? So, alright. If I add any other questions, it might do with lists. I've only got 5 so far, and I have to write an exam, and I'm trying to finish writing the exam tonight, so... the questions might have multiple parts, you know, 5-point parts in them, just like the other one. But for right now, right now I'm just trying to keep it short because these are programming questions, and I don't want you to have to worry about your time as much. Make sense? It's already being recorded. Okay. So, let's go ahead and share my screen. There should be only one regex question. It would be, if it was going to be similar to anything, it would be very similar to the Social Security regex question. But, like, I won't require you to use regex. So you can use if statements or the like. But, like, for looking for a pattern, it might be more helpful for you to know how to use your regexes. So it's the same as the last exam, because it's going to have the same requirements as the last exam. Okay? Mind you, so just as an FYI, like, I had, for question 3, I had this whole thing about, like, Canadian postal codes, and I had, like, not for question 3, but, like, on the exam 3, I had this question about Canadian postal codes, and people just went and looked up a regex for Canadian postal codes that were more stringent than what I had, right? So the requirements were way more stringent than what I had, and they just copy and pasted it because they found it on Stack Overflow. Just because somebody posted on Stack Overflow doesn't mean it's the answer to my question. You know, and pasting code like that, I generally just mark those as 0 and move on, rather than trying to unwind them. Yes, if you took exam 3, it means I'm dropping, and I've adjusted the exams. I've adjusted the grading policy so that your weakest exam should already be dropped. Right, so your exam average should be what your exam average is at this point. By this Saturday would be great. I'm probably not. I'm probably going to take a look at it when I'm going to assign my final grades. Make sense? So, no, I'm not going to post the answers for exam 3. Sorry. You can ask me you can ask me what you did wrong, but I don't post the answers to my exams. Yes, the exam grade should already be dropped. Okay. Now, let's get started with this. Notable things. 5%. So it's an easy 5 points. Alright. So write a script that, given a text file, finds and returns all the superhero words in it, which are words that end with man, woman, boy, and girl, and such as Supergirl and Batboy. We did that for the practice on exam 2. I'll skip over it for now. Let me go ahead and look at this. So consider the following list, which is a list of lists. What is the length of this list? Which you probably discovered it is 4. Right? And that's because this list has 4 lists in it. Right? Here's our first list. Here's our second list. Here's our third list. Here's our fourth list. So this list of lists has a length of 4. And thus the element at index 2 is going to be 789. Yes, it's being recorded. Okay. And finally, what is the sum of list of 2? Well, if this is 789, then adding them together gives us, well, 7 plus 8 is 15, and add 9 to that is 24. All right. Here's a fun one, finally. So, and I might do some Project Euler problems today because they are useful, right? So, 2520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. 2520, so if we divide it by, it can be divided, it's saying you can divide it cleanly by all the numbers from 1 through 10, right? Divide by 1, it's going to be divided cleanly, obviously. Divide by 2, cleanly, obviously it's clean because it's an even number. Divide by 3, bit harder to check, but quick rule of thumb, if you can add up all the digits of a number, and that resulted number is divisible by 3, then the whole thing is divisible by 3. So 2 plus 5 plus 2 is 9. So 9 is divisible by 3, so this number is divisible by 3. Divisible by 4 because it's a multiple of 20. Same, it's divisible by 5 because it's a multiple of 20. 6, it's divisible by 2 and 3, therefore it's divisible by 6. 7's a bit harder, but I'll take its word for it. Divisible by 2 and 4, so it's divisible by 8. And same thing with 9. So, and 10. So you can divide it, so it's the smallest number that can be divisible by 1 through 10. There's no number that's smaller. Everybody understand that, the premise so far? So now we want to find the smallest number from 1 that's evenly divisible by from 1 to 20. Okay? So let's go ahead. We want to find the smallest number that is divisible by all the cleanly divisible by all the numbers from 1 to 20. Okay. So ITP assignments. Euler 5.py. The Project Euler problems are really good for beefing up for math and programming practice and using them in conjunction with each other. So let's write a function def find Euler 5. And now here we can use modular arithmetic. Print find Euler 5. And again, one thing that I keep seeing in the exams that people lose points for is I say return in a function and people put in print. Or I say use a list, and people don't use a list. They use a string. You got to use that. Yes, there's going to be a Monte Carlo problem on the exam. I'm going to look through and find one, practice one to do today. So, okay. So, let's go ahead and do this one. So, here we want to find a number. So for I well, I mentioned that there would be one in the previous lectures. So for I in range, and I did mention that it was cumulative. So so here, because we don't know what number we're going to go up to, I'm going to say what I is equal to 0. Well, I'm going to start out at, let's say, 2520. We know that's the smallest number that's divisible by all the numbers 1 through 10. So while and let's go ahead and say, while not done. My personal favorite way of doing things. So done is equal to false. The hardest part about this is setting up the loop. Okay. So while not done, what we're going to do is that we are going to rather than writing a big loop here, I'm going to say if div by, or div, sorry, if fulfills requirements, then I'm going to return, then we found our number. So if our number I fulfills the requirements, we return it. So there's no need for this done. We can just simply say, while not true. Sorry, while true. If I fulfills the requirements, return it. Else, I is equal to I plus 1. So basically, we're just going to say, hey, is this So here, what we're going to do is just simply say, hey, as long as the thing doesn't, as long as the thing fulfills the requirements, we return it, because that will be the smallest number that fulfills that requirements, because it's going to be the first one we encounter. Otherwise, we add 1 to it and check the next number. So here, let's go ahead and write the fulfills requirements. It's nice to break it up to make it easier to read, because otherwise we're going to have a for loop inside a while loop, because what I'm going to do is I need to make sure, by default, it's not going to return. By default, we're going to assume it fulfills the requirements, because we can check dividing it against each of the numbers, and as soon as we find a number that we can't cleanly divide by, no longer fulfills the requirements. So we just simply move on and return false. So for number for div or divisor and in range 20, 1 up to and including 20, so in that range, if number mod divisor is not equal to 0. In other words, if it doesn't cleanly divide, return false. Common mistake I keep seeing is that people will do this, else return true. That will just return true to just check is it divisible by 1. We don't want to do that. We don't want it. We need to check all the numbers. So we return true only when we're done checking. So we run it and hope it's running. Take a while. Let's see. Did I do something silly here? What did I mess up? Bug console. Okay, so what I'll do is I'll print I, which will let me know what it's testing. Did I not put in the function right? I don't need to put I here. It took forever to find the number, which it can do. Let's go ahead. Task manager. Right, the fun thing about Project Euler problems is that they can sometimes do that. Let me go ahead and quit folding at home for right now. And let's see. Close. Kill it. Yep. So, let's go ahead and think about this for a second. Definitely can go up by 2s because it's got to be an even number. And got to go up by 4s because it's divisible by 4. In fact, got to go up by 10s because we know it's got to be divisible by 10. So it can take a while to find that number. But now we're going 10 times as fast because guess what? So if it fulfills requirements, return true. So it can take forever. So let's see. Give me a second. I'm gonna make sure I didn't mess up by checking my my number. It is quite the big number, though. So it will take us quite a while to reach there. So let's go ahead and give me 1 second. But yeah, it will take quite a bit to reach there. Sometimes programs like this actually take a long time to figure that out. Let me just see if I ever wrote anything more efficient than what I currently have. Okay. Notes. Because I do a lot of Euler problems. Code. Euler 5. LCM brute. Is this Euler Project 5? Find the least smallest number. Yeah. So, number 5. We don't need to check 1. So we can check 2, but that's really not going to speed it up too much. But this will take a while, as somebody said. So if we remove the printing, though, let's see what happens. Because the number is 232 million. There we go. Sorry, it just... So making it go up by tens was what helped make it go longer. His tower knocked over.
Your tower knocked over again.
And his foot may be stuck, actually.
Right, let me see if I can help you. I got you, Laser. I might need your help, actually.
My son has gotten himself into a bit of a position.
Just wait for Daddy. I want you to do the picking up. Slowly. Okay. I saved you. Don't put your foot back in there, okay?
His new thing is looping his foot into stuff and getting it stuck.
I am?
All right.
I'm working outside in the yard.
All right. So the next question is sum digits. Given an integer, return the sum of all the digits. You may assume we are only dealing with positive integers. This one over here is because I still had students get it wrong in the second exam. So if I'm adding a question, you can expect maybe a question about this kind of stuff. Right? And here the idea is basically I might add a requirement of do not, assume number is a number and don't convert number into a string. So I might put that in as a requirement. Because I want you to focus on being able to use modular arithmetic. So how do we do this? Well, while num is greater than 0, total is equal to 0, while num is greater than 0, last digit is equal to num mod your hand now, num mod 10. I'm pretty sure you can get your hand out yourself. Yeah, I think you're just fibbing on me. Now he's playing the whole I'm pretending to be stuck for attention. My wife is currently working on in the garden, so last digit. Okay, total is equal to total plus last digit. And now num is equal to num mod 10, or divided by 10 to get rid of that last digit. So grab the last digit, add it to our total, divide by 10 to throw away the last digit. Write a function that returns true if the string can be spelled the same front and backwards. There's a number of ways to do this, so I'm going to go over with the really clever one-line solution. Palindrome. Oh, palindrome. Is it palindrome? Yeah, palindrome. Okay, we want to know if it's the same front or back. Okay. Wait a second. Can I do that? No. Shame. I was thinking I could totally do an emoji in there, which would have been hilarious. Word. Alright. So. But the easiest way to do this is return word, or the shortest way to do this is return word is equal to word, which simply says return if word is equal to the same thing reversed, then hey, that's true. Otherwise, return false. But suppose we weren't comfortable as we should be with our slicing, then reversed is equal to the empty string. You're in a boat? Carry you in the boat? I can't carry you now. I'm working. I'm trying to help my students. Okay, reversed. For I in range length of word. So what I'm going to want to do is I want to start at the last index, which means -1. There's a number of ways to do this. -1, go down to, but don't include -1, and we're going to go down. So in other words, go in reverse. Versed is equal to word of I so that will, and now we return reversed equals word. So here what we're doing is that we're going through the word in reverse and we're sticking it onto the end of reverse. So say our word was wolf. I'm sorry, we're looking for palindromes. Well, let's go with wolf anyway. So we'd start at index 3, get the F. Then we'd go to L and stack that on the end, and then we'd get the O at index 1, and then we'd get the W at index 0. So we would get we would compare wolf to flow, which are not palindromes. So that would return false. On the other hand, if we have race car or taco cat, right? Let's go with taco cat. With the T at the end. Oh, sorry, we'd start at the last index, which is T. Then we'd add the A to the end, then the C to the end, then the O to the end, then the C, then the A, then the T would get added to the end, and we'd see spelling it in reverse gives us the same thing. You're stuck again? Laser. Okay. Mm-hmm. There. I put you down there. Okay. Not like that. I'm sorry that I could not. Let's take a short. Just give me a second to deal with this, or to handle this. Yes, Laser. What's up? You want me to carry you again? Okay, but I'm working now. I can't just drop everything and pick you up instead right now.
Go downstairs.
I can't bring you downstairs. Whoa. Hey, Annie, are you there? Laser, I'm busy working with my students. All right. Another way to do this one. Hi, Laser. Another way to do this one is actually pretty interesting, which is to do it like this. You just go through the letters normally. Letter, 4-letter in word. And what you do is you're going to add letter plus reversed. Rather than doing reverse is equal to reverse plus letter, which would add it to the end, we add each letter to the beginning. So let's go with our example with wolf again, because that's easier to show. Right? So what we're going to do is that we would add, we'd start with the W, and we'd add it to the beginning of reversed. Then we'd go to O and add that to the beginning of reversed. Then we'd add the L and add it to the beginning of reversed. Then we'd go to the F and add to the beginning of reversed. Right? Doing the letter plus make you a tornado. Well, I think to be a tornado, you have to stand up and spin around a whole lot. I think you were asking me to make you a burrito. I showed my son how to wrap himself up in a mattress yesterday, so. Well, tornadoes, they spin around.
Oh, all right.
Oh, all right.
Yes.
I don't know if there's going to be multiple choice on this exam. We'll see. But I'm trying to make it so that regex is not necessarily is an additional feature you can draw on, but not necessarily required. If that makes sense. Okay. So we did this one for exam 3. All right, yeah, this one's definitely tougher, as I mentioned, than what would appear on the exam, but I like this one. There might be. I don't know if there will be an extra credit question. We'll see. I mean, but we'll see what I can do. I'm just trying to make this as easy as straightforward as possible. I mean, once I go through this exam, I'm going to cover a bunch of the stuff that specifically that I want to do. So, count 1. Okay. So here, we're trying to see if the things are permutations of one another. And what makes this tricky is that you don't necessarily, you might necessarily have not gotten what you needed to know from, you're not necessarily comfortable with permutation versus combination. So, let's go, so to see if two things are permutations of each other, right, let's go ahead. Word permutations. I'm just going to find some ones that are good. Let's go with. So basically, like, I'm trying to find 2 good words that are permutations of each other. Well, I mean, wolf and flow are permutations of each other. Okay? While they weren't palindromes, they were it's a convenient example. And what makes them permutations of each other? Each of them, they have the same counts of characters, right? There's 1 W, 1 O, 1 L, and 1 F in each of them. Also, what would be a permutation is if I sorted it out, flow is sorted alphabetically. How about that? Let's see. loaf, whatever that is. That's a permutation, but is not a permutation because there's two L's, right, versus one L. So they have to have the exact same number in the of stuff. To do a more abstract example, here's a permutation. These two are permutations of each other. And this is a permutation. All three of these are permutations. That's more abstract. But this is not a permutation because we have a different number of B's here than we do over here. Does that make sense to everybody? So the way we are going to figure this out is that, as I said on the exam, is that we can count the number of. So what we're going to do is we're going to count the number of times each character appears in A, the number of characters each one appears in B, and if they are the same, then awesome. So what we do is we basically just do 2 word counts. So for a letter in word 1, if letter in count 1, then we are going to say count 1's count of that letter is equal to the count of that letter plus 1, or if we haven't seen it, the count of that letter. Just so FYI, apparently I'm going to be missing out on seeing ducklings because I'm giving you guys a review session. So, sacrifices are being made on my part. And then we do the exact same for word 2. We count all the letters in word 2. If it's been in our second count, we add one to the number of times we've seen it. Otherwise, we say we've seen it for the first time. And then all we need to do is return count 1 equals count 2. I plan on trying to make it fairly easy. Okay, there shouldn't be anything that gets you pretty lost. It's going to be broad but not too deep is the hope I'm going for. Okay. Before I continue on, let's see. Actually, this one's pretty good. Below average. Given a list of numbers, return a new list of all the numbers from that list that are that are less than the average. So the key here is that most likely we would have to go through this list twice. We can also if you know your Python, you can do it much shorter, but we're going to just assume we need to iterate through this list of numbers. So let's call this. So first we need to return a new list, right? It's important that when I say you return a new list, that you follow that direction. So below is an empty list, and we're going to return below at the end of that. And so now we got to figure out our average. Okay, our average, first up, we got to add all the numbers in numbers, and then we got to divide. Average. So for number in numbers, average plus equals number. And then we get our average by, of course. I wish I could, but I gotta help my students. I love you too, Laser.
He loves you helping your students.
He says he loves that I'm helping you guys. All right. So average is divide equals the length of numbers. Okay. Sorry, I'm dealing with like multiple conversations because of that. So anyway, so below. So here what we do is we go through all the numbers. We add them to our average, and then we get our actual average by dividing by the number of numbers we have. right? You just can't go through it once. You have to iterate through it twice, even if you do so in one line. Because the other thing we could do is just simply say that the average is equal to the sum of the numbers divided by the length of the numbers. Sum of the numbers divided by how many numbers there are. That gets you the average. Okay. Okay. Now, finally, we have to find how many of these are below. So, for either of the approaches I showed works. I like this one because it's short. So, for number in numbers, there's nothing stopping me from doing this twice. I'll just show you. There's nothing that will stop me from doing this. For number in numbers. So now we go through the numbers and say if number is less than the average, right? We're trying to get all the numbers that are less than the average. Some students were doing a return here. Don't do a return. Don't try to make it a string. It's a list, I said you want to return. So you do low dot append. And what you're going to do is append the number. So if the number is less than the average, then we will just simply add it to our list and return it that way. Okay. Append, what that does is that it adds the item to the list. It's a very, very useful method, and you should definitely know it for the exam. If you call append, so a list using dot append adds the thing in parentheses to itself. So here below will add number to itself. Very important to know for the exam, because anything that deals with lists, I will probably say, hey, I want you to return a list of things. You want to do that. The other way to add things to a list, by the way, which looks a bit more hacky, is to say below is equal to below plus, and then you put the other thing in another list, and that will concatenate those two lists together. But you have to put in the brackets. Doesn't look as pretty. Okay. Sum of tens. I'll do this one, but there's not going to be like a nested list one on this exam. Normally I focus more on nested list stuff, but I didn't want to this semester because of the teaching online situation. So, return all the integers in the list that are multiples of 10. Okay. So here, it's a list of lists. So what we've got here is sum of tens. We've got numbers. Not numbers, but yeah, numbers. So numbers is a list of lists. So we know it's like two-dimensional. It's nested too deep, which means we need two loose lists to go through it. So let's create a total. We're going to return that sucker. Return it. Total equals 0. Return it. Now, what do? We need to go deeper. So for, and I'm going to say for each list, I'm going to call the variable each list, just to make it sound grammatically correct, in numbers. Right? Because remember, it's a list of lists. The list has a bunch of lists in it. See? So for each list in numbers. And then we'd say for number in each of those lists. Might be better to say, rather than saying each list, maybe doing inner list. Yeah, that's a better idea. For the inner list for each inner list in number, for each number in the inner list, numbers versus number. So I'm going to do n for n in inner list. If n, so now if the number is divisible by 10, total plus equals n. So we're going to add it to N. And that's all you need for that one. It's rather short, but it's just understanding that you got that nested for loop. I'm going to try to avoid having a question like that in the exam. I'd much rather have a question that deals with file reading that says, hey, can you find like all the people that are over 5'5"? Like, here's a list of people with, here's first name, last name, height, weight, gender. Find all the men, return a list of all the men, return a list of the names of all the men who are over 5'5" in height. Right? That's more the kinds of questions I'm trying to look for. I'd probably be doing if that involve lists. Okay? Because that seems a lot more. Am I going to go over those? I will. Once I'm done with this. Once I'm done with this document, which I almost am. I'm going to go over I'm going to do a couple questions on the fly. Make up a couple questions on the fly to go over a scam question, a question like that. Well, let me go ahead and actually do that. And let me go ahead and actually make a question like that right now. Let's go ahead and suppose we have a CSV file. Okay. Let's go ahead and make it. Called. Yeah. Let's go ahead and make it call it. So first off, I put this in the wrong place. Save it in IT. Shouldn't go in here. It should go in. Classroom, ITP, summer 2020, Bloom. And also it should probably be called final review.py. There we go. Now let's go ahead and save it here. I'm going to call it peeps. Called CSV. Doesn't matter what file type it is. Don't want to. But let's go with Alice. I do have office hours today. I'm going to do office hours today, I should rather say. So Alice Adams. Alice Adams, let's give her and say she is 65 inches. And let's say she is 130. Let's go with Bob. Bobson. Let's say he is 70 and 250. Kathy Kathson. Let's say that she is 10 and weighs 1,000. She is 10 inches tall and weighs 1,000 pounds because we're not fact checking this. Dan Danson 999 2 pounds. Okay, whatever. Doesn't matter what the point is, right? What we want is, let's go ahead and say our problem is here, given a file, let's just go ahead and keep it simple. Find all the, return the name of all the people who are over 5 feet, over 5 feet tall. Okay? So, over 5 feet tall, which is 60 inches. So, def file reading prob, given the file name, right? Return the number, return the names of the first name and last names of all the people who are over 5 feet, tall, which is 60 inches. So, open. And this, so first off, doing this, doing just open is not enough to read the file. This just opens the file to be read. That was a mistake I saw a lot in on the third exam, where basically people thought they could do this. And then they would basically do re.search, right? You wouldn't use regular expressions for this problem, but they would do re.search, or sorry, they'd do their regex, and then do find all using their regex on the text, but the text hasn't been read yet. We just simply we have just opened it to be read. That's what text is. So for line in text, that's how we read it. Or you can just simply, or you could do line.read or whatever. But I'm going to do for line in text because it's a CSV file, and that's easier. So for line in text, output is I'm going to, here is our names for the output. It's going to be a list because we want to return all the people. List of all the people. So for line in text, first thing we need to do is split the text. Split on the commas specifically because it's a CSV file. So now, what do? We have 4 things in this file. We have our fname is equal to line 0. Lname is equal to 1. Height is equal to line 2. And that will be and we're going to turn that into an integer. And then weight is the last column. Turn it into a integer, and turn that into an integer as well. And now we've got all of our fields. And the question is, the only thing we care about, is this person greater than taller than 5 feet? So if height is greater than 60, and for those of you who are coming from a metric-centric system, a sensible system which uses centimeters, and is not used to using American freedom units, I will provide like any conversions like that, so don't worry. So if height is greater than 60, then that is a person we want to add. So we would do names dot append fname plus space plus lname, so that we would have a space between the first name and the last name, right? Because we want the full name of the person. So that would work on that one, most likely. Okay. In a similar vein, given the name of a text file, return the sum of all the numbers in the text file. This is also similar to what I would like to give. Each line in the text file is composed of integers separated by commas. So that in this file might look like that, right? Separated by commas like that. So what we're going to do is def sum file. I'm going to assume that I'd be specific about saying you have a file name as a parameter. So let's go ahead and open it up. Data is equal to open file name R. Sorry, Frozen's currently playing in the background. I'm going to turn it off. There we go. if I'm uploading this, I don't necessarily want it to get taken down by an automated bot. So it would be copyright infringement since I'm not actually doing any criticism or critique of the song Frozen. So Tom Scott did a wonderful 40-minute video. Was it Tom Scott or Tim Scott? He did Tom Scott. He did a wonderful video on YouTube and the way YouTube deals with automated copyright stuff. So some data. So we want to add all the data. So for line in data. Okay, so now we're going through line by line. Same deal here because it's separated by commas. We want to say line is equal to line dot split. And now we're going to turn this line from a string into a list with each element being what's on the either side of the commas. So that would turn this string into 3, 4, 5, 1. And this would be 10,000, 1, 2, 3, 1, 2, 3, 5, and 3 for the second list. Right? So now we've got something. Now we have to go and add up all the numbers in this. So for num in list, in the line. So for every number in the line, first thing we got to do is say num is equal to int num. And then I need to put an accumulator in so that we can actually add up our numbers. Total plus equals int. Return total. Okay. Let's go ahead and check out a Monte Carlo problem. So give me 1 second to find one. Did I do one with flipping coins as a practice problem yet? Anybody remember if I did that? Okay. Yeah, and it was, what is the odds of, what are the odds of, file name won't have quotations around it because it's a parameter, it will contain a string. It's a variable. So, did I say did we calculate what the odds were of flipping 5 heads and 5 tails? I believe I did that. Mm-hmm. Mm-hmm. Yeah, I did. Okay. So, let's go ahead and see. Let's see what I can do for here with this. We had Penny's game, which was fun. Let's see if there's anything similar there. So, right, we did Penny's game as a practice exam in the practice exam. Let's see. Let's see. What is a game I could calculate the odds on? Because I'm trying to make sure I've got, because I need two. I need one for the exam and one for this one. So, let's say. That actually sounds pretty good, actually, for a practice problem. Look up dice scams, and I would say look up dice scams, card scams, and coin scams. Which I'll. There are a couple ways that can be. Yeah. So, yeah, there's a couple of different scams. Razzle. I'd try to look up and simulate Razzle. That would be quite that. It's mainly to make sure that you guys can look at scams. Scams basically take advantage of the fact that most people are naturally trusting, and they aren't suspicious, especially if they think they can, be the ones to win money, or to get one on over another person. So let's see. Play for Razzle. Okay. So oh, but you just throw it into there, so why? Interesting. That is... So there's a couple of suspicious gambling games out there. Let's see. So Razzle, for instance, or Razzle Dazzle, scam in Carnival Midways, historically in Havana, Cuba. Right, that one is you've got this playing board, 10 or more, 10 points or more win. Right, which is that you've got these 100 hole. It's paid on that's a scoring chart, and you can see with any kind of arrangement like that, it's not necessarily that great looking. So you've got you spill 8 marbles onto the board from a cup, and they land in holes, and then you add them together, and then if you get totals, then the different totals, like totaling up 13 is worth 5 points, 43 is worth 5 points, and so on. So these do not... It's just... Here's... Somebody wrote a simulator for it. A flexible simulation for the Razzle... Somebody did a simulation in Razzle for here. So there's lots of different ones, but honestly it's dice games that really are the things to check out. But what I'm going to do is I'm going to go over a fairly simple problem, and I'll find a different one for the exam. So the idea here is that all right, so we've got we're going to flip 3 coins. If we flip a coin, it's an independent action, right? Flipping the value of one coin does not affect the chances of another coin, right? So we flip a sequence of 3 coins. Flip the first coin, second coin, third coin. So if they all come up on the same side, you get double what you bet. Otherwise, you lose your bet. So they all have to come up on the same side. And the scammer points out, well, we know that 2 of the coins, right, are gonna match no matter what, right? And this is true via the pigeonhole principle. We have two sides of the coins. 3 coins. 2 of them are gonna be the same side no matter what, right? So 2 of them must match. So that last coin is gonna either match the other 2, in which case you get 3. Otherwise, it's gonna land on the other side, right? And you lose. So 50-50 shot, right? 50-50 shot. 2 of them are going to match no matter what. So that last coin, right? That last coin is going to basically be 50-50. This is not true, of course. So let's write something to simulate this, right? Okay. So let's figure out what the real odds of this game are. Everybody understand the premise? Flip 3 coins with independent flips. If they all come up on the same side, then the payout's 2-1. So you get twice of what you get 2 coin. Actually, you get $2 for every dollar you put in. So that would be great. So you bet 100, you end up with $300. Otherwise, you lose your $100. So since one of those pairs are 3 coins, since, 2 of the coins are going to match, then this appears to be a good deal because now it's just a 50-50 shot, right? And if it's a 50-50 shot, then, and you're winning triple payouts when you win, then long term, you definitely win more money. You just got to keep playing. Obviously, that's not the case because nobody would be playing this game if they were going to lose money. So let's go ahead and do def 3 coin Monty. Okay, so let's go ahead and create the number of trials. Let's do 100,000 trials to simulate this. First things first, let's create a function called import random. And let's create a function that, let's see, what should we do? We need to import a function that, let's create a function that just creates a random, that creates our sequence of 3 coin flips for us, right? So def create 3 flips. Okay. Flips. Is equal to a list. And then let's go with result is equal to a list, and then sides is equal to, you either have a heads or a tail. Okay. And actually, let's make this a string because, yeah, I don't know, result works fine because we're just checking to see if all of them are equal. So, let's go ahead and flip one. So, random, so 4i in range 3 because we're gonna flip 3 coins. Result dot append random dot choice, which is the way to randomly choose something from a list. You can also generate random numbers like 0 and 1, right, or 1 and 2. The lowest lab should already be dropped, I think. If not, I'll get to it. It's random dot choice sides. Nice. Bam! So, we've got that. And now what we got to do is for blank in trials, we're going to make a dictionary to keep track of all the lists of all the results. Actually, don't need to. We can just simply say wins is equal to boom. So, for wins in trial, we can do create 3 flips, create flips 3 flips, the reason I have it in caps is because that's generally the way you do constants like that, things that you don't want to be changed, or big so it's just a way of saying this is a constant. This is if you want to change something that's going to affect the entire program, you can change that. So game flip So we're going to do flips is equal to create 3 flips. So we did our flips. And now we've got 3 flips, and what we got to check is if flips 0 is equal to flips 1 and flips 1 equals flips. Oh, that's something I always like doing on the final. Now I remember. So there will probably be a question on the final exam along the lines of something that here's a new thing you haven't learned yet. Here I completely explain how to use it. Please use it to solve this problem. And you'll have the access to the internet, so it'll be pretty straightforward. But basically, the ability to learn something new on the fly. So here, if flip 0 is equal to flips 1, so if the first is equal to second flip and the second flip is equal to third flip and the first is equal to third, in other words, if all the flips are equal, although actually I think you can actually do if flips 0 is equal to flips 1 is equal to flips 2 in Python, but you know, I have to switch between Python and Java. So basically, if all 3 things are equal, wins plus equals 1. Right? So now we do that and then print wins divided by trials. So let's figure out what the real odds of 3-coin Monte is. Int object is not iterable for I in range trials, of course. So your real odds are winning a quarter of the time, not half the time. Now, of course, why is this? Because when you're flipping 3 coins, you actually have 8 different combinations. You have head, 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 and you have tail, 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 where they all match up. But you have head, you have head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head. Right? So I got a question. You've got is 1 is equal to 2 and 1 is equal to 0 equal to 1 and 1 is equal to 2. Yeah, the last part isn't really needed logically because if 1 is equal to 2, because we're saying if 1 is the same as 0 and 1 is the same as 2, then we already know that 1 is the same as that we'd already know 0 is the same as 2. Thank you. So here we have 8 possible combinations when you flip 3 coins. Yes, you're always going to get 2 that match, but there's 3 coins and then there's 8 different ways that can happen. Right? Because yes, if you don't care about the order in which you do things, then it's a 50-50 shot that you're going to get it. But if you care about the order, which you do, because first coin, second coin, third coin, you're going to get head. You can have head, 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 tail, tail, head, tail, 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 head, tail, head, tail, tail, head, and tail, tail, tail. There's 8 possible combinations, only 2 of which win. So you only win with a quarter of the possible combinations. So those are the odds. Right? So basically, it'll be probably something fairly simple, which is just simulate some kind of coin flipping or dice rolling kind of thing. Nothing too complicated. All right. any other kind of questions that I can go over? No, the detecting fraud goes to the overall home lab grade. The exam questions, the way I've decided to just handle with exams and weighting them was to do those 3 exams. I don't have office hours besides today, but that doesn't mean you can't demo at other times. You just have to schedule a specific time with me. So if you're not ready to demo today, or you want to avoid the rush, because there's going to be a ton of people who want to demo, you can demo at a different day. Just schedule some time with me. So to review what is going to be on the final exam, we have the following questions. We have a question which will involve numbers, for loops, if statements, modular arithmetic. That's one of the questions. We'll have a file reading question, much like the one where we had to read the file and find the person, all the people, and return a list of all the people with over a certain height, right? We had to, so we'll have some kind of file reading question. Practice, go over the exam, the problems from the other exam that you missed and try to answer them. Third question will probably be something that will be a lot easier if you know how to use regular expressions. So, the fourth question that I'll have is I'll have a turtle question on there. So go back to exam 1 and examine that. Turtle question, basically, here's a picture. You know, try to recreate, give me code that basically will recreate this picture. Or, yeah. So yeah, because other questions I would have that were easy to auto grade, they don't really take into account. They wouldn't be easy. They'd be solvable easily just by copying and pasting your questions into the computer. So I have to do something like, here's a picture. Please render it. And it's not going to be too hard. It'll be fairly straightforward. Question 5 will be something regard to questions. Actually, I might turn the turtle question into something like... Actually, scratch that. The turtle question probably was best combined with something like your Hurricane homework assignment, where basically you had to move the turtle by reading a file. Question 5 will be a Monte Carlo scam game. And if I'm gonna do and I think I'll do a 6th question where basically I'll give you something you haven't seen before, something I haven't taught in class, and I'll tell you exactly how to use it. And then I'll ask you to use it to do something fairly straightforward. Because I'm a big fan of that. So we'll probably have 6 questions total. Probably 6 questions total plus a freebie.